All right, today we're going to work on something called completing the square. And before we jump into that, I want to cover standard form. Standard form we've been talking about since Unit 1, so hopefully you're familiar with it. Standard form is when we order our terms from highest exponent to lowest exponent. And specifically for quadratics, we're going to represent it by ax squared plus bx plus c. And a and b just represent coefficients, so I could have remember a coefficient is a number in front of a variable, and c is going to represent our constant or a number without a variable. To introduce this idea of what we're going to do today, we're going to start by distributing each of these expressions in number 1. And I want to remind you that to be squared means to multiply something by itself. So this is like all of the quantity x plus 5 times itself. And so now we have to distribute. So I get x squared plus 5x, and then I could distribute the 5 through, and I get plus another 5x plus 25. And now when I combine like terms in the middle there, I get x squared plus 10x plus 25. Okay. We're going to do the same thing for b and c. Remembering that I'm writing it twice because to be squared means to multiply it by itself. And we're going to do it one more time for good measure. Remember, x minus 7 is being squared, so I'm going to multiply it times itself. Now we distribute. And there we go. Okay, so all of these that we just found are called perfect square trinomials. We call it a perfect square because it came from a squared binomial. This is a squared binomial, you know. Remember, binomial means two terms. And so this is like a parentheses with two terms in it being squared. That's what a squared binomial is. And so the result of that, each of these is called a perfect square trinomial. And I want you to just look at some patterns of what's going on here. And so talking back with standard form, how does the b coefficient, aka this middle coefficient here, so our b, middle coefficient, how does it relate to the number in the squared binomial? Let's take a look. 10 and 5, 6 and 3, negative 14, negative 7. What I'm hoping you're noticing is that b is twice the amount the number in the squared binomial. Okay. Well, now how does the number in the squared root binomial relate to the constant c? So this number at the end, 25 and 5, 9 to 3, 49 to negative 7. What pattern's going on there? What I'm hoping that you're picking out is that c is the number in the squared binomial squared. So you see that? So for example, a, to get from 5 to 25, I square it. Example B, to get from 3 to 9, I square it. C, to get from negative 7 to positive 49, I square it. And so what I want you to see is we're going to kind of connect those all together now into this box over here where it talks about the relationship. For us right now, we're only looking at expressions where A is going to equal 1 from standard form, which is why we have this down here where it doesn't have an A there. It's because A is going to equal 1. But if I wanted, what I want you to notice is that with C, it's the number in the squared binomial being squared. But how do I even get to that number that's in the parentheses? So let's look at number 2, part A. I want to rewrite x squared plus 6x plus 9 as a squared binomial. So it's going to be something squared. Well, I'm going to tell you for this, since A is going to be equal 1, all of it's going to be x. Well, if we look at example B that we did up in number 1, that was x squared plus 6x plus 9. Well, how do I get to that 3 in there? Here's what I hope you connect. I can take this B and I can divide it by 2. So since 6 divided by 2 is 3, then I'm going to get x plus 3 squared in there. And so for part B, I can do the same thing. I'm going to start with an x, and what I'm going to do, negative 20 divided by 2, I get negative 10, so that's going to be an x minus 10 being squared. Part C, I'm going to start with an x. Negative 18 divided by 2, I get negative 9, so it's x minus 9, all of that being squared. So that is how we're rewriting perfect square trinomials into squared binomials, and what this is going to be for our rule down here. We're going to assume that this x squared plus bx plus c is a perfect square trinomial, and the relationship that is going to happen, this is going to be x plus b divided by 2, all of that being squared. And that's that relationship. So number 3, determine if the following are perfect square trinomials. Well, we need to make sure if it's a perfect square trinomial that these two conditions that we just picked out are met. So 3a, x squared plus 10x minus 11. I'll give you a second to think about it. Our answer here is no. And we have to explain how we know. What I'm hoping you're realizing, x squared plus 10x, it's really the constant at the end is what's going to tell me if it's a perfect square trinomial. Because if this was a perfect square trinomial, if we look at example A in number 1, x squared plus 10x plus 25, it should be a plus 25. And a way we can check that is it's going to be a perfect square trinomial if this c equals b over 2, and then we square that. That's the relationship that we picked out. So in order to explain this, what I could say is that negative 11 does not equal 10 over 2 being squared. Because 10 over 2 being squared, well, 10 over 2 is 5, 5 squared is 25, so that should be a 25. Well, let's check this one. Part B. Negative 8 over 2 squared is what should be here. Negative 8 divided by 2 is negative 4 squared, which equals 16. So this one is also no, because 64 does not equal that negative 8 over 2 being squared. The reason all this is coming from, once again, I just want to point out that this is the relationship that we're looking at up here. It's the relationship of perfect squared trinomials and the squared binomials. These are just patterns that we're picking out. And so this box here that we wrote our stuff in red, that's really what's going to guide us through. So I'm looking at number 4. Find the value that completes the square. This is the idea, the title of the lesson, completing the square. Completing the square means all we want to do is find the value of C that creates a perfect square trinomial. And so we're going to do what we did to test with number 3, x squared minus 10x. Well, all we're going to do, we're going to apply this condition, b over 2, and we're going to square it. So negative 10 over 2 squared. Negative 10 divided by 2 is negative 5 squared. I'm going to write that a little lower. And we get 25. That is the value that completes the square, aka the constant that creates a perfect square trinomial. That means this relationship exists. So I can do the same thing with part B. I'm going to take my middle coefficient, I'm going to divide it by 2, and then I'm going to square that. 36 divided by 2 is 18. 18 squared, I definitely don't know off the top of my head, so I'm going to stall for a second while I grab a calculator. Okay, 18 times 18, 324. That is the value that completes the square. We're going to do the same with part C. Take my middle coefficient, which is negative 12. I'm going to divide it by 2, and then square it. Negative 6 squared is a positive 36.